In this 7th lecture, we are going to continue with the same topic, that is Panda series. Series, just we discussed its creation and few methods in our lecture 6. We shall continue uh, with the following topics. First of all, we are going to find various statistics for a series, for example, mean, standard deviation, etc. We are going to find common elements in two series. We can also find frequency count for each item in a series, and then we shall discuss how we get the previous and the forward values of a series using the shift method. We can also use the percentage change function to find changes in the series value. And most importantly, how do we find series methods online? So we don't know how many methods are available with Panda series. So this is the agenda for today's class. Hopefully we can finish this and we can add more items to it. Okay, so we are going to start with the first topic of today, that is finding descriptive statistics of a series. So once we have a series, we can very easily find descriptive stats, for example, mean, standard deviation, minimum, maximum, and similarly several other descriptive statistics. So let's start by creating a Panda series. As you know, before using Panda series, we have to import this library, import pandas, and we will use the abbreviation of PD. So we are importing pandas as PD, and once imported, then we can create pandas series. So let's create our first series, call it S1, and since we are importing this function from the pandas library, we are going to first tell Python that the series function will be borrowed from the pandas library. So also remember, we need to create a series with the method series where its first letter is capital. So once we have written that, we need to provide Python list. So let's create a random list of several numbers. So this is our short series. It has 4 elements, and this is the common practice that once we have created a series, we can also call it an object. Then we have to write the name of the object, and then we apply the method to that object. So let's say our method is to find mean value of the series. So we typed the name of the series and then we applied the mean method to it. Similarly, we did not store this value anywhere. If we want to store this value for later use, we can then type the we can assign this value to a variable. So let's assign this to a variable a, or we can assign it to a more appropriate name, that is mean. Mean is equal to name of the series, and then we apply the method mean. So let's run it, And now let's also find another descriptive statistic, that is standard deviation. So we type the name of the series and then we applied the method. It says we cannot find the method std. Okay, and let's see what is the standard deviation. The standard deviation is 40. Okay, let's give this a name of SD and assign it okay. Similarly we can find minimum. I think the series name and the method of min, and we can find maximum. So we type the series name s1 dot max and we get the maximum. Let's store this in the variable max and we can type out the value of the these variables, and we can also type the output of this variable. So this is how we create a series and then we find the descriptive statistics of a series. Remember, series is a sequence of numbers. It's a dimensional array of numbers. So if you want to find all descriptive statistics in one place, the most commonly used descriptive statistics in one place, we can type the series name and then we can type describe. So it will give us the most common descriptive statistics: count, mean, standard deviation, minimum, 25th percentile, 50th percentile, that is also median of the series, 75th percentile, maximum, etc. And we can store this specific let's store this in variable s2 and let's see what is s2 so we can find the type. So s2 in itself is a series, so we can apply further methods on s2, but the point is that the output that we get from describe command, it creates a panda series and it has all these specific descriptive statistics that we might be interested in. Okay, next we can compare two series, and instead of comparison we can find elements of one series in the second series. So this can be useful where we want to identify common elements or non-common elements in two series. So let's create two series. Let's create series 1 and using the series method from the pandas library, provide Python list. So let's create a simple list of 1, 2, 3, 4, 5 and also create another series s2 equal to pd dot series, provide Python list. And let's now input just several odd numbers. So now we have two series, S1 that creates natural numbers and S2 that creates odd numbers. We can apply the method of is in to compare whether one series is available in the second series. So if you want to find whether series 1 is present in series 2, rather whether series 2 is present in series 1, so S2 is in series 1. Okay. So how do we read this specific output? We typed S2 is in S1. So it is like asking a question whether S2 in series 2 is present in series 1. Since we first of all identified series 2, the output that we get will be equal to the number of elements in series 2. So we have 3 elements in series 2. This is why we are getting 3 rows of data. And if in the element at index 1, if it is present in series 1, we will get true. If it is not present, we will get false. So let's see what happens if we type it like this. S1 is in series 2. So this is how this is what we get. Now remember, we typed S1 as a first argument. This is why the length of the series that we get from this command will be equal to the length of series 1. Series 1 has 5 elements, and here we also have 5 elements. So the first element is present in both the series, that is 1 1. This is why we got true. The second element of series 1, it is not present in series 2. So therefore we shall get false for this. Similarly, third one is present in both, fourth one is not. So this is how we get all the results. And if we store this specific result, let's say in variable bol, we can find the nature of bol or the nature of this specific series. So let's type of bol. It should be a Boolean. So it's a panda series and it's a Boolean series because we are getting true and 0 and trues. So my next question would be, what are those common elements of the two series? What are the common elements of these two series? And we can get the common elements of the two series by slicing, using the slicing notation. So we type S1 and we slice those items which are present in both of these. So we saw here, if we type bol here, you see that we get true for the first element, we get true for this for the third, and we get true for the fifth. So therefore you remember that we can slice items from a series using Boolean notation. So if we provide the Boolean series to this, we get the elements from S1. So these are the elements which are present in both the series, and these are the elements which are actually there in the Boolean series where the value is true. So the item at the first index, we have a true value for that, and this is why we are getting 1 from the S1 series. So in this specific example, we saw how do we identify common elements in two series. So we do this using the is_in command, and we also saw how we then extract those common elements. So we type the name of the larger series, and we supply the Boolean series that we got in the first step. So this is how we then obtain the common elements from it. Once you have some practice on that, then I'll show how to obtain those non-common elements. So let's say we want to get only 2, 4 from S1 because 2 and 4 are not present in S2. We can also do that, but before that, I'll like you that you practice on first identify the common elements, and second obtain those common elements. We can use the tilde sign here, that is below the escape key. We can use this sign to find an inverse of an object. So if we want to, let's say if I type BOL, I get this specific series, and if I type an inverse of it, it will reverse the notations. So where it is true, we will get false, and where we have false, we will get true. So this specific notation can be used to an inverse an object or series. So therefore, we can easily identify elements which are not common in both the series. So if I type S1, and then I use an inverse of the Boolean series, we get those items which are not common in both the series. So 2 and 4 are present just in S2, but they are not present in they are present in S1, but they are not present in S2. So this is a small tip or trick that we can use when we have a Boolean series. We can easily find an inverse of that by using this specific symbol. It is on the Windows keyboard. It is located just under the escape key, and we find it. We can enter it by pressing the shift key and the button below the escape key together. Okay, our next topic is getting lagged and forward values of a series. So let's go back and try find out what we had stored in series 1. We have 1, 2, 3, 4, 5. So let's recreate the series with some different values. PD dot series, and let's redefine it. Let's provide some hypothetical share prices. So let's say the OGDC share price on different days are as follows. Starting with 104, then the price of the share goes to 108, it comes down to 106, then it goes to 109, and finally it goes to 112. So these are the hypothetical share prices of a company. Now let's try to find the previous values of the series on different days. So if I want to find that, I can use the shift method. Okay. So what does the shift method do? It actually creates a lagged value of the given series. So on the first day, we have 104. So with the shift method, this value has been so on the first day we don't have any previous value, so this is why we get not a number. On day 1, the previous value of the share price was 104, so this is why on day 1 we get 104. In the original series, 104 is on day 0, so let's call it today. So on day 2, we have the value of 108, but the previous value is 104. So with the shift method, we get the previous value. And similarly, on day 2, what was the previous? On the index 2, what was the previous value? On index 2, the present value is 106, but the previous value is 108. So this is why we have 108. And if we provide one inside shift, we actually get the same results. So shift without argument and shift with one, they are identical. So now let's provide 2. Okay, now we are creating 2 legs. So how do we read this specific series? So on day 3, index 2, what were the values 2 days ago? So we are talking about this specific observation. So value of this specific series 2 days ago was 104, and the same has been written here. So the argument inside the shift specifies how many legs we want to use in this specific series. Okay, what will happen if I type S1 shift and then S1 shift 2? So what we are doing here, we are deducting, rather instead of, let me type it like this, S1 and then S1 dot shift. So here we are deducting previous value from the current value. Since we don't have previous value for day 0, we should get not a number. But over here, the current value is 104 and the previous 108, and the previous value is 104. So the difference between these two should be 4. And this is what we get. On index 1, we get a 4. That is the difference between 108 minus 104. On index 2, we have the value of 106, and when we deduct the previous value of 108 from that, we get minus 2. Okay, and can we find percentage change using the same method? Yes, this gives us change in absolute value, And percentage change can be obtained by dividing this whole thing, this difference, on the previous value. And the previous value is actually s1 dot shift. This is actually the previous value. So this is exactly the formula that, how we find the stock returns. So stock return formula is equal to current price minus previous price divided by previous price. So this is exactly what we have typed. So this should give us the percentage changes. So the percentage change between 0 and 1 is 3%. And how is that? 108 minus 104 divided by 104. And if you want to show this in 100, we can multiply it with 100. So this is, we got all the numbers in percentages. So the shift method, with shift nothing or shift 1, we get the previous value of a series. And if we provide with shift 2, we get two period lagged value. And similarly, if we use shift 3, we will get 3 periods lagged value. We can also find forward values with shift minus. So let's go back to our series, that is S1, and let us use shift, and this time we provide the argument of -1. Okay, so for day 0, what is the next value? So the next value is 108. So this is what we get. And for day 1, what is the next value? It is 106. So on day 1 we get 106. On day 4, what is the next value? We don't have it. So this is why on day 4 we don't have any value. So using the negative value with shift, we get the forward or the lead values, and using positive values with shift, we get the past or the lagged values. So let's have some practice on that, and then we shall continue. Using the shift method, we found the percentage changes in share prices, but we can also find percentage changes using another method, which does not use shift explicitly, but it uses shift internally. So if you want to find percentage changes, we can apply the PCT change method. And it gives us exactly the same result as we use the shift method. If we multiply 100 with that, so if you compare, the first percentage is 3.84, the second one is minus 1.85. 3.84 minus 1.85. So it is up to the user to use whether the shift method or percentage change method. But shift method is more flexible. We can use lagged values, we can use forward values for finding different rate of changes. Okay. Now let's search for some other most useful series methods using our internet search skills. So here is the our first search, the results of our first search. We search for what are the most common series methods, and this is the first one we get from the internet. So this one, head and tail, is used with the pandas data frame. So let's forget about it for the time being. We can also use unique. We also found the value counts method for that. we have already done that. And it says that it uses the len function to find the unique values. Okay, so let's add this unique to our list. Okay, describe, we have already discussed the describe method. It's also is not available, or that is used for finding the missing values. Okay, then we have group by, we shall discuss that in our coming lecture. D types and S types. So to find the data types of series values, whether it is a Boolean series or it is integer, float, or we have also shape and size that is also used with data frame. So I think we have covered almost all important topics in this. Let's go to our second search. This is the, so we can use size method, we can use the count method. So concerning this topic 7.6, what are the most common series method? I think we have covered majority of them. Some of them are still to be covered, but those will be covered in our data frame discussion. So let's discuss what is data frame. Data frame is a combination of series. So series is a single list of data, and data frame is a combination of two or more series. So it is just like a spreadsheet. We have number of rows and number of columns for that. In my previous experience, I recall that many students struggle when they import data into Python from files. So let me show how we can import data from a website. For this purpose, I'm downloading data from opendoors.pk. So if we go to opendoors.pk and then go to courses, data science, and then we go to lectures, and then lecture 4. There I have posted several data sets. I'll copy the first one, that is the TCSV. The file extension is TCSV. So this is the tab separated file. Other files are CSV, which are comma separated. I'll copy the link of this file. So copy link address and store it in a Python variable. I'll call this variable as URL. So as you can see, I have assigned this whole text to URL. Since this is text, I have closed this text in double quotes. So let's run it. And if I want to print what is the contents of this specific variable, it will show again the same link. Okay, since I have already imported pandas library, and so I'll use its function read CSV. No matter it's a CSV file or TCSV file or text file, we still use the same command, read CSV. I'll assign the imported data to a variable data frame. pd dot read CSV is the function. Read CSV is the function from the pandas library, and the first argument is the variable that in which we stored the URL. We could have written all this text in double quotes over here instead, but to save space and to have the command in neat form, I have assigned this whole URL to a variable, and now I'm writing the variable name here. The default delimiter is comma. So if it's a CSV file, we do not need to use any further options with it. So this will be enough. But since this is not a comma separated file, it's a tab separated file. So I'm specifying another argument, and I'm using /t that specifies that this specific file is a tab separated file. So the Python will copy this data from the website and store it in the variable df, which is a data frame. So let's run it. It will take some time, and once it's complete, we'll see the execution number. So this is 51, so we got it, and now let's run it again. Let's see what we have in df. So we have this data. This specific data has 1704 rows and 6 columns. Each column is a pandas series, which we have been discussing. So continent is a series, year is a series, life expectancy is a series. And we can apply the methods that we have just learned on all these series. Data frame and series are different in a sense that data frame is composed of several series. So each column can be considered as a series. This data frame, if we do not type anything with the data frame name, it will print some initial rows and the last rows to give us the idea of how this whole data set looks like. I can specify a method .head. This method prints few initial rows of the data frame. So it prints 5 rows. If I want to print more than 5 rows, let's 50 rows, so I'll df head 50, so it will print the first 50 rows of the data. Okay, let's remove the argument 50, and we are okay with the initial 5 rows. It gives us the initial 5 rows. Similarly, we can use the method tail that will give us the last 5 rows of this specific data frame. And as I said that each line is a series, so how can we apply different functions of the series? So the name of this data frame is df, and if I want to get a specific column out of this data frame, so I'll have to specify the column name in double quotes. So let's go to population. It gives us the population column out of this data frame. So what I did, I wrote the data frame name, and then I, in square brackets, which are slicing notation, I specified the column name. And now I can apply any series method. For example, we talked about the describe method, which gives us the most important or most frequently used statistics of a series. So now it gives me the most common descriptive statistics for the column population. Similarly, if I am interested in another column, I'll just enter the name of that column inside the parentheses. And now we have descriptive statistics for the GDP per capita. Similarly, if I want to have descriptive statistics for life expectancy, I'll put the life expectancy here. So this is how we can now play with data frame in a similar fashion as we did with the series. So I think that's enough for today. We shall inshallah continue with this topic tomorrow. Until then, it's goodbye, and I'll be here for a few minutes if you have questions. Thank you.